So our discussion is all about the introduction to data structure. This is chapter 1. So let me discuss to you about algorithm. So during CS 1 to 6, we've already discussed what are algorithms and what are the types of algorithm. Again, when you say algorithm, it is a computational method for solving a problem. It's also a sequence of steps that takes us from the input to the process down to the output. So there are different types of, there are two types of algorithms. We call this as the flowchart and the pseudocode design. So if you're going to review and recall what is the definition of pseudocode and flowchart is a graphical representation of a sequence of steps. Okay, while pseudocode is a written instruction that a human can easily understand. Now, when we say algorithm has this characteristic. Number one, it must be correct. So again, when you say correct, it should provide a correct solution according to the specifications. So meaning to say, you know already what are the requirements needed when you are doing the algorithm. If you still remember, before we solve the problem or before we solve the machine problem, we analyze it first and we check if the requirements are correct or not. Then of course, an algorithm must be finite. Finite means it should terminate. So that means if you still remember that a flowchart starts at a start or a lozenge symbol, okay, so that means we have the start and then we have also the end. For pseudocode, we have the word begin and we have the word end. And then it must also be a general, okay, or it must be general. It should work for every instance of a problem. So if you input something, for example, you are taking the sum of two numbers and you input 12 and 15, should have a resulting value of 27. And if you have to change the value for the first number is 7 and the second number is 5, you should also get a correct result, which is 12. So it should work for every instance of a problem. Next. Wait ha. Okay, last characteristic of an algorithm must be efficient. So it means that it should use only few resources. So when we say few resources in a computer system, we are talking about the time or the memory needed to solve the algorithm or to solve the problem. Now, again, as mentioned a while ago, there are two different types of algorithm, and these are the flowchart and the pseudocode. But here in data structure, we usually use the pseudocode, which is an English-like representation of the code required for an algorithm. So this is actually the most common tool to define algorithms, specifically the programmers or the developers. Now, let me just give you an history of programming concept. So it started with a non-structured or linear programs, meaning it is actually known as the spaghetti code, and the logic flow going through the program. So when you say linear program, it's just like a main program in C++, and all the tasks and procedures is actually processed within the main only. That's why we call it linear. While modular programming or structured procedural, for example, in C++, main is already calling a function. That's actually a modular programming. So that means main will not perform all the tasks, but rather it will call a procedure or a function within the main program. So that is a program organized in function, each of which still use a linear coding technique. Okay, so again, when you call a function, when you perform the task, it is also considered as a linear coding technique. And the other type of programming concept is object-oriented programming. So when you say object-oriented programming, functions are developed around an object. And one part of the object-oriented concept is what we call encapsulation. So there are different types of concept within object-oriented programming, and these are just one of the example, which all processing for an object is bundled together in a library and hidden from the user. when we're talking about object-oriented programming already, it's not already, we call it function. For modular, we call it function, but for object-oriented programming, we call it already as methods, okay? Now, we all know that there are different types of constructs or different types of statements when we are dealing with algorithm. So the easiest one is the sequence. So when you say sequence, it's just a series of statements that do not alter the execution path within an algorithm. So it's just simply like, for example, you have the start, and then you accept the value or input the value. Then once you input the value, just process whatever uh, unknown you need to perform, like for example, getting the sum. So you just input two numbers and then process the sum and then output the sum. So that's just a sequence. But for selection, it's already like a decision making. You evaluate one or more options or alternatives. So in this case, we use already like in C++, we use